You know, the plow seems to be symbolic of that can-do spirit that you find in American farmers. And so when you say that there may be better alternatives to tillage for compaction relief, that seems somehow counterintuitive and almost un-American. I met two guys from Ohio State who use science to put conventional wisdom on its head.
We're trying to tell the farmers that you cannot solve your problems with steel. You know, steel is shiny, you can put your hand on it, you can spend a lot of money on steel, and even with a subsoiler that may have minimal surface disturbance, it's really not solving the problem. You know, we're seeing that soil structure can be better solved by using natural rooting systems through our cover crops or continuous no-till from the cropping systems. And we have some other experiments here that are proving that. We have some compaction plots comparing subsoil, steel versus living cover crops. We're purposely compacting these plots in the fall under moist soil conditions by using a grain cart and going back and forth over the plots and forcing that compaction. And then the cover crops are planted, and then we're comparing that to using a subsoiler, and our yields are showing better results with the cover crops. And of course, when you get some heavy rains, you can see standing water problems, you know, that show up between the compaction levels of the plots also that way. And the cover crops are outdoing the steel.
So what's the explanation for these rather surprising results?
When you look at a soil, you have to look at the components. And the major component of most soil is sand, silt, and clay. Now, that makes up about 45% of a really good soil. Yes. The other part of the soil, what we tend to forget about, is it should be pore space. Almost 50% of a really good soil is pore space. But then the most important part of a soil is the organic matter. That's like your head and your brains. That controls most of the chemical reactions, and most of the life is with that organic matter. You know, when you start to till a soil, what you do is you burn up the organic matter. So in the last 100 to 150 years through tillage, we've lost probably at least 60% of our organic matter. Some studies say as much as 80% of the organic matter is going right up into the atmosphere. And this is a good area because this was the Black Swamp in northwest Ohio. When the first settlers came here, they said our soil was as black as midnight. And when you look at the soil now, you'll see that it's not as black, it's actually kind of a brown. It's lost its color, so it's lost a lot of its organic matter. I like to tell farmers that a lot of times when you till the soil, you turn it into cement mix. Okay, and so the soil gets very hard and dense. And one of the things that we've learned is that if I was going to drill into cement, I would start with a small drill and then use a bigger drill to go through it. And so that's what we do with the cover crops. The cover crops actually have very fine roots, and they form a small hole. And then we follow that with corn and soybeans. And those corn and soybeans will follow those same channels down through the soil. And they also follow earthworm holes because earthworms are fairly big and they're also enriched with nutrients. Yeah. And so those roots just really proliferate around those earthworm holes. Okay. And that's how we then can actually loosen the soil up, is it's the roots that loosen the soil up and give that carbon to the soil, and also is a storehouse for all the nutrients in the water.
So a lot of innovation is happening. It's really an exciting time because farmers are seeing that, hey, there's different ways we can improve our soils by adding cover crops, you know, by not going to steel, by reducing our tillage. A lot of good innovative thinking, I think, is happening.